I also help organize the GDG Montreal. I'm going to spend my time talking about me, so I don't even have a slide for it. So I'm here to talk about coroutines. And I put the title, The New Kid, on the Async blog, but I could very well also call it the old kid in the Async blog, because actually coroutine is not really a new concept. It's actually something that exists a long time. Many ideas of coroutines are very, very old. Simula 67 was one of the first languages to introduce coroutines, and the reason is that in the past, we didn't have multi-threads, we didn't have multi-process, so we had to find a way to run code in parallel without causing many issues. So that's when they came up with coroutines in a different way of implementing of how we have today. The idea was there. Coroutines are a flavor when multi-threading came along. So multi-threading came and it became easy to use it and everything. So people was just like, you know what, I don't have to make my code even more complex by adding coroutines. The issue, today we can find coroutines ideas and implementations in many languages. In JavaScript, maybe because JavaScript, you don't have threads in JavaScript, so they need a way to do multiple things at the same time. You can also find it in C#, Python, and other languages. What's the motivation behind it? Why do we need coroutines nowadays? Why is it coming back in fashion if one day it was dropped out? It's because we're writing more and more async code. Everything is becoming more and more async. At some point, we stopped doing that, but with the web, with modern web, JavaScript, and even mobile, asynchronous is cool again. Some platform like Android, it's almost completely async. It's not only about just async tags or worker thread or UI thread. When you think about or calls to the backend, when you think about the views itself, it's almost asynchronous. When you create a view programmatically, you don't know when the width is going to be calculated, when the height is going to be calculated. You can do listeners, you can put the listener on the global layout to figure out when that thing is going to be available. But it's completely async. It's based on the hierarchy, it's based on the system, it's based on a lot of stuff. You also have the on resume, on pause. You're not really sure when the user is going to press home or not. So other things makes Android a completely asynchronous platform, if you think about it. Threads are a bit expensive and not available everywhere, like Python and JavaScript. And writing asynchronous code can be complex. If you write Android, you may know that, and I don't think I have to sell that motivation. If we take a look at async codes nowadays, for example, this small piece of code, here it's a very, very simple code. There's nothing async about it yet. I'm just getting a token, and then I'm going to use that token for whatever reason to post something somewhere, and then I'm going to process the result of that. One of the options that we have today is callbacks. So I can just use callbacks in Kotlin, and I can have the information of that, so I can have asynchronous code. I can call prepare post async, and I'm going to have at some point a result that is going to give me back a token, and then I can use that token to submit post async with something, and then I'm going to have a result. At some point, I'm going to process that result. The issue with this is you can see right away, if you ever wrote listener to a button that does a call to something else that have a result, that does a global layout listener that have a result, you know where I'm getting. It's very complex, very complicated. You're writing a lot of code for nothing. You may even end up with this, right? You're going to get a lot of what we call the callback hell, and it's going to be very complicated. Of course, you can try to fix that by putting whatever you're doing, your result, your listening, your implementation of that listener or of that callback to another class, to another function But what you're doing is you're splitting out the code that should be together, and it's making the code review more complicated. So you're not really solving a problem, you're solving a problem with another problem. We can do promises of future, or what RX Java likes to call single. The nice thing about it is that it has no nasty indentation. So the problem that we saw earlier, we don't have it because I'm always return objects. I'm always returning composables, and I can work on those composables, so I can work on it later, and I can do one after the other, like if it was synchronous, like if it was one after the other. So it makes the code easier to read. And it propagates exception. If you are ever handling exception, it propagates to the beginning and make things easier to handle if you ever get an error or something like that. The issue with it is that you have so much to learn. You have so much composition. Like, for example, map, flat map, switch map, merge, just, each. Every single one is different. Promise is different. Future is different. Array single is different. If you want to do any modification on that result, you have to learn how to do when you're using that API. So if you want to go through the list of the results of your call, you have to know if you should call a flat map, or if you want to use a switch map instead, which I didn't even know existed until like months ago when I had to use it. So like, it's always a constant learning that it can be very upsetting. And if someone new comes to your team and it's reviewing your code, it's gonna be like, what the fuck are you doing? I have no idea what those methods do. So it can get pretty complicated. So let's see how this method would look like with coroutines. That's it. It looks a little bit familiar. It does. It looks like I'm doing a non-asynchronous call, a non-asynchronous method. So all I have to do is put suspend there on the bottom to my function, and it's going to return some value, in this case a string, or it can be something else. And then I have to call that method inside of a coroutine builder. We're going to see what a coroutine builder is later, but in this case I'm using launch, which is using a comma poll, which it's like a worker thread, and to call whatever is inside it. So what's going to happen here is that when I call prepare post async, for example, that code is going to stop there. It's going to wait for the result before calling the next line. And because I'm calling that inside of a launch, that's not going to stop, that's not going to block my thread. The nice thing about it is that we can use everything that we can use on Kotlin. We can use regular loops. I can go on a for, and I can call my method that use coroutines inside with no problem. I don't need to use a map, a flat map, or something like that. I can do a regular exception handling. I can just do try catch. I don't have to figure out a special way of doing that. It's like I'm writing real code. It's like magic is happening. And I can use high-level operators. I can use let, apply, repeat for each, filter, map from Kotlin, which are very useful on that one, to call that function with no problem whatsoever, without having to worry about in which thread I'm calling it or anything like that. So how does that work? So what's the suspend function? So in this case, let's say I have this very simple suspend make request. There is a suspend function. When I'm gonna transform that on JVM, on Java, what I'm going to do, I'm gonna add a parameter to that method that is gonna be called continuation. And it's not available when you're using Kotlin. You don't need to care about it. But basically what continuation is, it's an interface. And it's actually a callback. You may think, oh, but I don't want to use a callback. But actually, you're not using Kotlin is using it for you, so you don't have to care about it. And all it does is to resume or to pause whatever it's in that code. This is a very much simplification of how it works. It's much more complex than that, but you get the point. So how does this block of code work if I'm calling it on in a builder, on a coroutine builder. So what it does is going to transform that in a state machine. So when you're going to go see the Java code of that, it basically put that on a switch, and it puts every step of that block of code in different cases. So in that case, on the first one, it's going to prepare the post, and it's going to say, look, I just passed through 0, next one it's 1. So I'm going to prepare a post. When I get the result of that, I'm going to pass through my switch again, and I'm going to go to the next case, in which case I get the token, which is going to come from the previous result, and I'm going to use on the next call. You don't really need to know that. It's just to give you an idea of what's going on in the background. And this is not really specific to Kotlin. If you take a look on the implementation of any coroutine, be on C#, JavaScript, Python, they basically use the same way of doing it. They transform it on a state machine. There might be some very small different details about each of the way of them to work, but they are all basically the same. So let's see, for example, if I want to use a call, an API, or a method that works with callback, and I want to transform it on a coroutine. How does that work? So in that case, for example, I have this method called makeRequest. The implementation is not imported right now. I get a request, and I get a listener, and this listener is going to give me a result. This is a callback that's going to give me a result of throwable, or something that went wrong, or it's going to give me a result. So if I want to transform that on a coroutine, it's a method that can be called from a coroutine, like a suspend, using suspend in that case, I have to put suspend at the beginning of the method. Remember, this is a new method that's going to call the other method. And I'm going to put the result that I want from it. After that, I'm going to call the suspend coroutine in this case, and the suspend coroutine is going to give me at some point a continuation, which is the count that we have at the end. With that, I can call the regular method, makeRequest at the beginning, and pass a request. In Kotlin, you know, if your last parameter is a callback, it's a listener, you can put it out of the parentheses. So that's what we're doing here. And that listener is going to give us an exceptional result. So, and those are nullables. As you can see on the top, they have an interrogation point. So we're just going to check my exception. Is it not null? If it's not null, that means there is a throw error, and then I can just get my continuation and say resume with exception. If not, I can say continue with resume on result. That's it. That's all you have to do if you ever want a method that uses callbacks to work with coroutine. That's what you have to do to transform it on a suspend method. The most complicated part here is to know what's going on with Kotlin, right? If you're not used to it, or if you're used to Java, it's really going on with things like, for example, when the listener is the last parameter, I can put it out, and lambdas and all this stuff. You can do the same thing with the other one, with the prepare post, and use it inside of the coroutine builder. To start a coroutine, you can't just use a suspend function anywhere. So if you ever have a suspend function that's just declared on your project, you can't just call when you feel like calling it. You remember, suspend functions are not necessarily coroutines. They are methods that are suitable to be used inside of coroutines. So you need to create a coroutine to use that suspendable method. The suspendable functions are what the name actually says, are functions that can be suspended, that can be paused and resumed at any time, depending on who's using it. To start a coroutine, we need something called coroutine builders. We just saw one not long ago called Launch, and we may have other ones. If you take a look at Launch, it's just something that I have to wrap my piece of code with. So in this case, my prepare post async, submit post async, or suspend method. So that means I have to call it inside of coroutine. So to create that coroutine, I have to use Launch, And then I can say if I want that launch to be called on the UI thread, on the background thread, whatever, then everything is good. I'm gonna call my method and all's great. What if you see the details of launch is a fire and forget, you can just call it, it's gonna return it right away and you can use it after. You can also, if you want that piece of code to be called on the UI thread, all you have to do is just say UI on the parameter instead of common or something like that. So now you can use your suspend methods inside of that. Async. So if you take a look at coroutines on other languages, have anybody here have ever seen coroutines on other languages? Two. Okay, so when you go to C#, you can use async and await, which are modifiers that they have, so you can use coroutines. Kotlin likes to leave the way you want to use coroutine up to you. The implementation of it up to you. It doesn't want to impose anything. We do have async, but not as a modifier. We have it as a coroutine builder. So just like we used launch not long ago, we can use async. And the difference that it makes is that it returns a promise as a deferred result. At some point, you may think that you want a promise. You're like, I don't know, I feel like having a promise, so just give me a promise, and they give it to you. You use async. So if you take a look at the beginning, Kotlin lets me have a function that returns value. In this case, it's returning me a deferred result, which is what async returns to me. Function, launch, the other coroutine builder that we just saw, returns a job. In this case, async returns a deferred result. With the job from launch, you can cancel it, you can join, you can do other stuff. This one you can also do different stuff, like for example, getting the value when you feel like. So you can just create two variables and put your method in there. It's going to call async. Async is going to return a deferred result, which is actually a promise. It's just another name for promise. They don't like to use all the same name for some reason, but they all do the same thing. So you can, and then you can call await. So basically, await, what it's saying is that, look, let's wait for the result of that. Let's wait for that coroutine to finish before continuing. To wrap up, it was a very short talk. To wrap up, Kotlin only had the suspend keyword. Like I said, it doesn't have await, it doesn't have async. But what it does, it transforms suspend functions to callback, compiles codes to state machine, and the lib only has continuation and continuation context, which I just showed you, which helps you transform your code on something that is considered usable for a coroutine, suspendable, as you may want to call it. Everything else is a library, so launch, that we saw it not long ago, join, async, await, run blocking, or anything like that, those are part of Kotlin X.coroutines, which is a library given to you by JetBrains. Like I said, the reason why they do that is because they want to give all the power, and now everything that you want can do or cannot do with coroutines on your hands. It's an experiment. When they say an experiment, it's not that it doesn't work well. It actually does work well. It works properly. It's not going to bug your application or anything. It's just that it may change in the future. The same way that Swift 2 to Swift 3 completely changed, this may change too. But it's, like I said, it's 100% usable, and I think the community should use it to make it better, so you can give feedbacks and ideas on how to work it in a better way. JetBrains guarantees backward compatibility. So if you wrote your code using coroutines from Kotlin 1.1, when Kotlin 1.2, 0.3, 0.4 comes out, your code is still gonna work. But they don't give any forward compatibility, so that means that whatever comes later, it's for sure not gonna work on the old versions. They also give themselves the right to change the whole API, so if you learn it in a way, they may change it on another way in the future. So today we don't have models, we don't have observables or single or everything that we do with Rx Java. So like, for example, how do we cancel things? How do we do this? It's a little bit of a different way of thinking about it, but maybe in the future they're gonna change that, we don't know. There's so much more about coroutines that I didn't talk about, because it's a complicated subject. I think for people that are not used to asynchronization or things like that, you can have channel, actors, section synchronization, job hierarchies, and cancellation. For example, if you want to cancel a coroutine, you can save the return of a coroutine on your value, on a property, like for example, launch returns a job, and then you can call cancel on that job. But it's not only that, it's not that simple. You have to make your code cancelable. You may have to make sure that your suspend function can be canceled. Your coroutine can be canceled. So one way of doing that, you can do a while is active, which is a property that is available inside of the coroutine builder. And inside the while is active, you can do whatever you do on your code. So every time it's gonna run, it's gonna check, did I call cancel, did I call cancel, did I call cancel. It's not amazing, it's not beautiful, but it works. So you can take a look on the details on how that works later. Build sequence and use with future promises and reactive libraries, just like I showed you how to transform a method that uses callback to use a suspend function. You can do the same with promises and future and reactive libraries, and also how the magic works. I showed you a bit how things are written in Java, but there's so much more going on behind the whole thing. I could talk for 2 hours if I was going to show all that. You may be asking, why do I want to use coroutines then? Like, my life is already complicated. I do Android, Jesus. Because things are getting complicated. Because if I can somehow find a way to have multiple code running on the UI thread and being non-blocking, we may we make fewer problems with lagging on the UI. If anything is blocking, why is my UI gonna lag, right? So I don't have to care anymore if my things are in the UI thread or not. I can make things faster. Coroutines are lightweight, so you can create 100,000 coroutines in 1 second. You cannot do that with threads. So there are many reasons why you want to maybe try coroutines and wish that it's going to be successful, and nothing stops you from using it together with your Rx Java library or promises or future or even Guava for some reason. But you can't. So it is something that you should actually look forward to, and that's it. It was short. Thank you.